Good afternoon, everyone, and welcome to this webinar, which addresses the polyamide mowing line applied to floating offshore wind turbine, their reliability and behavior. So I'm Nicolas RUIZ, I'm Research and Development Manager at France Energy Marine, and I will be the chairman of this session today. So this webinar is organized in the frame of MONAMOOR project. MONAMOOR means modeling and monitoring of nylon mowing line for offshore winds. It was a collaborative research and development project conducted by France Energy Marine and supported by French National Agency through France 2030 Fund. This project, as you can see, has involved several academic and industrial partners during 2 years and just ended at the end of beginning of November. So today we have several speakers who are going to present the work carried out and the result obtained in the frame of this project. So first we have Peter Davies, a researcher at Ifremer, Laure Sivier, a PhD student that conduct this thesis in the frame of this project and will join France Energy Marine soon. We have also Jean-Sébastien Verjus and Romain Ribaud, both research engineers at France Energy Marine. And Yann Marco, professor at ENSTA Bretagne, and Kawel Devos, research and development manager at Dexco rope manufacturer. Here you can see the agenda of this webinar, 1 hour and a half duration. So as an introduction, first we'll start by introduce the context and have a global overview of the project architecture. Then a presentation of advance in terms of behavior law, long-term effect and modeling will be present. And his second presentation will address, in fact, the buoy prototype deployed at sea at Mistral test site in Mediterranean Sea and the associated monitoring system setup that we are able to perform at the end of the project, comparison between model and measure, and also some in situ validation. Then we'll have a feedback of a rope manufacturer who was a partner of the project, Dexco, and in terms of outcomes that they can use for industrial uses, and also a way forward of the future research works. So during this presentation, you can post your question in the chat room, so do not hesitate, please. And after the technical presentation, we'll have an interactive session, and I will ask the speaker to answer to the question address. Thanks, and now I will give the floor to Peter Davies for the context and project introduction.
Okay, thank you very much, Nicolas. So I hope you can see the screen okay. I just have a very brief introduction to the project. Ifremer was the scientific coordinator, and there's a little bit to say about the context of the project, and then just the links between the different work packages which we were using to advance. So there've been a number of demonstration projects so far. There's some floating wind pilot projects underway, and in France there's some projects such as Provence Grand Large, which is currently being installed, and future project in South Brittany and a number of others. So the industry is moving, and if when we look at some of the predictions, this is a carbon trust prediction for the floating wind GIOP. We're looking at a very large increase. They're estimating something like 10 gigawatts in 2030 and up to 70 gigawatts in 2040, 2050. And the figures change all the time, but you can see there's a big market and a very exciting prospect for offshore wind. But there are still some technical questions remaining. One is the long-term behavior of the material which we're looking at the moment, which is polyamide. As we know from the offshore industry, that Single point moorings are generally replaced after 1 or 2 years, as they tend to degrade quite quickly in fatigue. So this is one aspect which has been studied by TTI in the UK, among others, and we're starting to get some data. But at the start of the projects, we had very little information on the long-term behavior of nylon ropes. Second point is monitoring. There is still no reliable instrumentation really available to indicate the state of the art or state of the health of mooring lines. So that's an area which we were interested in. And the third aspect is modeling. Nylon shows quite a complex nonlinear behavior, certainly more complex than polyester. And we really need tools to optimize design, but also to understand the behavior and try and interpret either monitoring or long-term testing. So there's a really strong requirement for more precise models of nylon ropes. And this is what we started to address in the Polyamide project, which finished in 2020, and then followed on with the MONAMOOR project, which we're talking about today. So it's monitoring of polyamide mooring lines. As Nicolas said, it's a combination of academic and industrial partners. And the project is set up with 4 main technical work packages. The work package 2 is development of the models, and that is piloted by ENSTA Bretagne. And the idea is to go from the 1D modeling, which we developed in the Polyamide project, to a more complete 3D modeling of sub-ropes and then full-size ropes. So Laura will talk about this in a minute. The work package 3 is monitoring. The idea was to try and develop more reliable monitoring systems to measure a range of parameters, principally the strain, but also other parameters which we could then correlate with the models. Those included optical fibers and acoustic emission. And this is just an example of a wire strain transducer, which is fixed on a clamp on the rope, which was finally installed at sea. The long-term testing, there were 2 aspects: there's creep and fatigue. ENSTA Bretagne set up a full-scale creep test rig, which is about 4 meters high, which we'll talk about in a few minutes. And then with Fonsenge Marine developed a demonstrator buoy mooring, on which we put quite a lot of this instrumentation, and which allowed us to get back some data from tests at sea. And John Sebastian and Romain will talk about that later. So I don't want to waste any more time. So we'll go straight on to Laura, who will talk about some of the work package 2 modeling and some of the long-term testing results.